Hi everyone. In this given problem statement, we are going to find the medium of two sorted arrays. We are given two sorted arrays num1 and num2 of size m and n respectively. We have to return the medium of the two sorted arrays. Let us take this example. Let us say we have two arrays of a, which is containing the value of 7, 9, 10 and 11. And another sorted array which is going to be B, which is containing the value of 1, 3 and 8. Now we can do merging of all the arrays. Let's say which we are going to calculate, right, which is the smaller. So 1 is the smaller, so our resultant array would be something like 1, then 3 is smaller, then will come 7 from the array 1, then it will be 8, 9, 10 and 11. Out here, right, our medium would be 8. So we can easily say, right, our medium is 8. So this would be the result of this one. But if I do this, right, our time complexity would be big O of n plus m, because you're traversing all the arrays one time. And here, right, it has been written that you have to find the result in big O of log m plus n. So here, right, only way for us to do it is using binary search. So to do it, right, the first thing that we're going to calculate are some values. We're going to calculate the total. So total would be length of A plus length of B, which is going to be 7 in this case. And then we're going to calculate what value or half value to find the medium. So half would be total divided by total double divided by 2, which is going to be 3 in this case. Once that is done, we are going to have our left and right pointer. So left and right would be 0 and length of A, or whichever is the greater, I'm just taking 1 out here, length of A minus 1. Once you have got that right, we can create our while loop. So while true, while our loop does not exist, right? So here we can have I, another pointer, which would be, let's say it will be something like middle element, right? L plus R double divided by 2. And then we are going to have J, which is going to be half minus I minus 2. Because out here, right, the value would be, right, because we are calculating I and it's a 0th index, right? So we have to do 2 minus, because there are two values out here. So that's the idea out here. So in this case, right, our R value is going to be 3. So it would be, if I just add it, right, 0 plus 3 double divided by 2, it would be 1. And half would be 3 minus 1 minus 2 would be 0, J pointer. Now we are going to have certain values. A left. The reason for using A left, right? So how you're calculating it, it's very interesting to do it. So A left of I, then A of right of I plus 1. Then we are going to have B left, which is going to be J, and B right, which is going to be J plus 1. So now let us take this example, right, how you're calculating up. So we found the middle element. Okay, so here, right, for the ith value, right, we are at this position. This is going to be our mid, okay? And j right is at this position. So to have three values, right, it would be like 1, then 7 and 9. That's the idea if I look into it up in that way. So I am saying, right, a of I, which is 9. Okay, right now it's going to be 9. So let me just add it certain things, right? So we are going to calculate these values. Now, if a of left is less than equal to b of right, and b of left is less than equal to a of right. In that case, right? So what I'm trying to say out here, if I look into it, right? So a of left value should be lesser than this one. So a of right is 9 less than 3, which is not true, right? So in that case, right, I can have some more condition. Let's say if a left is greater than b of right. So in that case, what I can do, I can increase our pointer by I minus 1. So if it's not smaller, okay, then I can increase the right value, right, to be increasing. So what I can say is that I am increasing the j pointer value to be a little bit more higher. So let's say if I increase it, right, now I minus 1. So initially, right, I value was 1 and our right pointer value in this case was 3. So it is going to get decreased and our r is going to be 0 in this case. So once r is 0, right, our j pointer is our I pointer, right? It will L is 0, R is 0, right? So it would be, if I remove it, 0 plus 0 double divided by 2, which is 0. So our ith pointer, right, is going to be decreasing because we know there exists an element 3 which is smaller than this 9, right? So we want to remove it up. And obviously our j pointer would also change. So it would be 0 minus 0 minus 2. So it would be 3 minus 2. It would be 1. So j is, as usual, is going to be out here. So j value is also increased. Now our current value of a left is going to be 7. A right is going to be 9. B left is going to be 3 and B right is going to be 8 currently. So now if I look into it, our A left value, right, is less than B right. So B right is 8. So 7 is less than 8. And B left, which is 3. 3 is less than A of right, which is 9. So we got our value. And there could be another condition, right? Else we can say L equal to I plus 1. And in this case, right, once you have got into the loop, right, I can check if it's an even or the total value is even or it's odd. So total percentage 2, if it's not equal to 0, then I can say, right, if it's an odd value, in this case, right, it's an odd value. So the value that we're going to find, it is going to be the middle element. So it's going to be return of minimum of A right minus or B right. In case, right, the value is even or the total length is going to be even, then it is going to be return of max of A left plus not plus, it would be A left and B left plus minimum of A right plus B right double divided by the total value. I can show you how it is working. So let us take this example, right? So we found our value. Now our A left, right? A left is 7 and B is 3. So it would be, it is, in this case, right, it's an odd integer. So it's going to be taking this one. So minimum of A right and B right. So here, right, A right is 7. Sorry, A right is 9 and B right is 8. The minimum, right, our result is going to be 8. So here, if you look into it, right, it's a very simple way. So let me take this example, right? These values are there: 7, 9, 10, 11, and 1, 3, 8. So initially, right, when you divided it up, right, our pointer was at 9 and the ith was at here. So if I look into it, so 1, 7 and 9 was coming, but there exists a smaller element which should be added out here. So this interpretation was wrong. So for that, right, what we are doing, we are decreasing our pointer from 9 to 7, and this value we are increasing to 3. Now if I add this value, right, it would be 1, 3 and 7. So we got the initial subset, right, or the left value. Then there is going to be 8, 9, 10 and 11. So this would be on the right side. So here, right, we are able to find our middle element or the medium. So in this way, right, we can traverse it up. And there is also one thing that can happen, which is a very exceptional case. In case what happens, right, in case we go out of bounds, so in order to tackle it, right, so we can say the any value on the left of right, it's let's say A of -1, or in that case, right, it would be minus infinity, and here it is going to be positive infinity. Same for B, minus infinity and positive infinity. So here, right, if our I is less than 0, then it is going to be minus infinity. If I plus 1 is greater than length of A, then it is going to be positive infinity. Similarly, right, if j is less than 0, it is going to be minus infinity. And if j plus 1 is greater than length of B, it is going to be positive infinity. So in this way, it's going to work. So here, right, if you can understand, right, how we have taken all these values and divided and subdivided into it, so it becomes very essential. Although it's a little bit difficult to understand problem, but I would suggest, right, once I write the code, right, you just draw it up in an paper and see how the functioning of the application works out, and I'm pretty sure you'd be able to figure the solution. On the first time when you're going to see it, it might look a little bit difficult to understand, but as you code it up, right, it's pretty straightforward solution. Now let me jump to the Python solution. Hi, the first thing that we're going to do, we are going to create two variables, A, which is going to contain our array of num1, and B, which is going to carry value of nums2. Now, the first thing that we're going to do, we're going to find the total length. If I merge both array1 and array2, right, what would be the total length? It would be length of A plus length of B. I can also do directly num1 and num2. I have to type too many things, so it's better to use A and B for this example. Then half. So half would basically write the index where our medium is most likely to be found. So it is going to be total double divided by 2 to get the integer value out here. In case, I'm also going to check which of the two is the greater value. So if length of B is greater than length of A, so in that case A comma B equal to B comma A. So whatever is going to be the higher value, right, I am always going to assign it to the eighth, means to the eighth, for our sake of simplicity of calculation. Now we're going to take our left and right pointer. So as we know, right, left is always 0 and R is going to be length of array 1, which is the higher size is going to be higher, minus 1. Now while true, we are going to find our ith index, which is basically the mid, if I say it in binary search term. So it would be L plus R double divided by 2 and j equal to half minus I minus 2. So we are going to find the index or the left side partition, right? I is basically for the array A and j is for the array B. Now we are going to check A left is going to be A of I if I is less than 0, to check for the bounding condition, else it is going to be float minus infinity. Similarly, A right is going to be A of I plus 1 if I plus 1 I greater equal to, it should be less than length of A, else it's going to be float of positive infinity. The reason for using this bounding condition I've already explained. Then B of left is going to be B of j if j greater than equal to 0, else it's going to be float of minus infinity, and B right is going to be B of j plus 1 if j plus 1 less than length of B, else it's going to be float of positive infinity. Once that is done, I am going to check if A of left is less than B of right and B of left is less than A of right. So in that case, right, our condition is fine. So the partition has been done properly. Now we're going to check, right, if total percentage 2 not equal to 0. So it's an odd value, right? In that case, we're going to just return the one value. It's going to be, so if it's an odd value, the total sum, right, we're just going to return the minimum of A right and B right, else, right, if it's an even value total length, right, we are going to return the maximum of A left, B left plus minimum of A right and B right, total divided by 2, and here right we have to return it in an floating point value, so don't need to do double division. Else, or let's say elif a left is greater than b right. So we are going to increase our right pointer to I minus 1. Else, if b left is greater than a right, then we are going to increase our left pointer by I plus 1. Simple binary search. Now if I return it, or if I run it right, it should work fine unless I make some spelling errors. As you could see, it is saying error, which is a right. Now let me run it back again. I hope it should work. Let's see. As you could see, the public test case is passed. Let me submit the code. Time limit exceeded. Let me check if I made some errors out here. After I carefully examined the code right, I found the issue. So issue is basically, in case right, the values are same right. So in that case also it's fine. We can go ahead with the partition and we can go ahead with returning the result. So here it would be a left equal to smaller than or equal to b right, or b left smaller than or equal to a right. So in this case, right, if I run it up, my test cases are going to run properly. And if I submit the code, the error that I was getting when both the values of num1 and num2 are same is going to get resolved. It is showing one more error, which is, it is saying it is out of bounds. So it is because of this issue. Let me resubmit it again. As you could see, it ran successfully. So I made one mistake, right? We are going to calculate, because we are going to take the bigger element b the first for the sake of simplicity. And let me rerun it again. It is giving an efficiency of 53.76. It is running in 2 milliseconds, which is pretty efficient for this type of problems. While recording this video, I know there are a lot of noises because I don't know why these stray dogs in my area started barking at 3 a.m. in the morning. So I'm very, very sorry if there are a little bit of background noises coming in this video, but just bear for this. I hope there is a lot of explanation that has been given out here, and please let me know in the comments, right, if those noises are literally creating problems. I can re-record this video again. I already spent like 3-4 hours, so it will be very difficult for me to re-record it, the entire thing. So I'm not re-recording for now, but in future, right, if I get some time, I will definitely try to re-record this entire video. That's all for this video. See you in the next one.